Okay, whiteboard is visible,
Yes, sir.
right? So what we have calculated, that is RA and RB. RA is equal to L minus X by L and RB is equal to X by L. Okay, as a simply supported beam that we have to consider. Okay, then we have to calculate R and RB. So now for two hinge, write down, for two hinge parabolic arch, for two hinge parabolic arch, the general equation of horizontal thrust is equal to integration of my dx divided by ei divided by integration y square dx divided by ei. Okay, so in general, okay, as I told, it requires 1.5 hours for the deriving the equation of the horizontal thrust for 2-inch parabolic arch. So already it is known to you that you have studied in your UG level. So the equation of H after simplification is equal to, please write down this equation, 5 by 8 W, that is 1 kilonewton load or the load on the 2-hinge arch, L divided by H multiply by X in bracket 1 minus X in bracket 1 plus X minus X square. So it is a function of X raised to fourth. H is a function of H raised to fourth. Okay, H is the function of H raised to fourth. Okay, it is X into X square and in bracket also X square. So H is the function of the X fourth, that is ellipse, right? Right? So now, all of you written, shall I proceed?
Yes, sir.
Okay. So now, we have to find out the value of H at A, B, and C, that is at A hinge, at B, and at the ridge, that is X is equal to L by 2. So at A is equal to, at A, X is also 0 from right support. So if you have to put the value of X in previous equation, so you get value of H is equal to 0, that is multiplying, right? Then when X is equal to L, that is at B, then H is also equal to 0, that is at B. Okay, then at C, X is equal to L by 2, at X is equal to L by 2. So if you to simplify the previous equation by putting the value of W is equal to 1 kilonewton, by putting the value of W is equal to 1 kilonewton, that is your applied, okay, LH, X that you have to put as L by 2, X that you have to put L by 2. If you have to simplify the equation by putting X is equal to L and W is equal to 1, so after simplification, you get H is equal to 25 divided by 128 in multiply by small l divided by H. Remember this value of H when X is equal to L by 2. Use the previous equation, put W is equal to 1 and X equal to L by 2. So H is equal to 25 divided by 128 multiplied by L by H. This is the standard value. Remember this, at X equal to L, H is equal to 25 by 128 L by H. Right? Yes, all of you are drawn.
Yes, sir.
Right? So as per the equation of h, it is function of x raised to fourth. It is a function of x raised to fourth. It is a cubic curve now. Okay, depending upon the ordinates, it is a cubic curve. So now at x equal to L by 2, h is the value of this. At a, x0, h is 0. At xl, h is 0. At c, h value is there. Now we have to draw the ILD for horizontal thrust. That is over. That is first part. That is ILD for horizontal thrust. Find out the value of H. H is the function of x raised to 4. Okay, you get the cubic curve, right? So now we have to draw the ILD for thrust. Okay, now as I told, you have to left one single page for drawing the ILD. तर त्याच्या अगोदर आपण एक ड्रॉ केली होती सॉरी टू हिंज आर्च त्याच्या खालती हे डायग्राम येईल किंवा ते डायग्राम जर असेल नवीन दुसऱ्या पेजवर तर नवीन पेजवरती एकदा ड्रॉ करा आणि त्याच्या खालती हे ILD फॉर हॉरिझॉन्टल थ्रस्ट ड्रॉ करा. So at C, the ordinate of H is 25 by 128 H by L. Okay, this is at D that we have taken the X, right? So this is called as ILD for horizontal thrust. H. Is it okay? Understood? Anyone having doubt? It is simple. Only you have to remember the equation of H. You have to remember the equation of H, then put the value of X, and then you get the value of H, depending upon the ordinate. Now I have taken at the L by 2. You can take at 1 meter also. So depending upon that, put the value of X in terms of L or at 1 meter interval. So you can also find out the ordinates of horizontal thrust H, and then you have to draw the ILD. Is it okay? Shall I proceed?
सर एल बाय एच आहे का एच बाय एल आहे.
Sorry, उलट लिहिलं का मी? L by H. Okay. L by H. Okay, sorry. Okay, this is ILD for horizontal thrust. Is it okay? काय अडचण आहे याच्यामध्ये? It's very simple. Only you have to remember the formula of H. So shall I proceed?
Yes, sir.
Right? Now second. ILD for next second. ILD for bending moment. ILD for bending moment. Now the diagram is with you. Don't redraw the diagram. Diagram is already with you. So RA is nothing but value of RA. How much it is? L minus X by L, and RB is equal to X by L. This value is already with you. Diagram also we have drawn already, so don't redraw the diagram. Right? Suppose this vertical distance as I taken y at point D. Okay, this your h, RA, x, right? So now for two hinge arch, around for two hinge arch, now moment about x, that is section x is equal to, okay, that is total mx of beam, means whatever the RA is there, right, minus h into y, right? Due to RA, mx of beam is nothing but due to the reactions, that is moment bending about x, right? RA into x, you get RA into x, that is mx of beam, and anti-clockwise h into y, right? About the section, and that is about point D, right? Shall I proceed?
Yes, sir.
Now next is, that is the equation of mx as we have written is equal to, continue, mx of beam is nothing but ILD for of mx of beam is nothing but ILD of mx of beam minus ILD of h multiplied by y multiplied by y, right? ILD of mx of beam minus whatever the previous formula we have written, mx of beam minus h into y. So now we have to draw the ILD for moment about any section, that is x. We have to draw the moment about the, we have to draw the ILD of moment about any section x, which is equal to now ILD of mx of beam, that is that section, minus ILD of horizontal thrust into y, right? So now mx of beam is equal to, next line, mx of beam, that is bending moment about x from support or from hinge A, mx of beam, mx of beam is equal to RA into x. RA is your L minus x by L into x, that is mx of beam. Now what we have drawn, that is ILD for bending moment about any section x is equal to ILD of moment about section of beam, that is due to reaction, minus hy is there, so ILD of h into y, right? So now this is your ILD of bending moment about any section. Now we have to draw separately the ILD of both the cases, that is ILD of mx of beam and ILD of h, right? Shall I proceed? Shall I proceed? Okay, now we have to draw the ILD of bending moment, right? So this is at point D, where we have calculated the This is point D where I am writing at top. जे तुम्ही ILD एक पेज ब्लँक ठेवलं होतं तिथे ड्रॉ करा. Okay, now this is the value of mx beam which is equal to L minus x by L into x. Okay, so for this, this will be the ILD of mx of beam, which is positive, Now, if you take the any distance in place of y घेतलात, ठीक आहे, y तुम्ही हा जो आर्च आहे, मी इथं सेक्शन घेतला किंवा इथे घेतला किंवा इथे घेतला. Suppose that y is now I am replacing by b. Okay, I am taking the vertical distance or the section that is about any point. So suppose that particular point having the vertical distance is your b, y is equal to b. So for this case, ILD of H, okay, suppose I am taking somewhere here the section, okay, or the point y is nothing but that is for ILD for H. So now right. So suppose I am taking somewhere here. So this ordinate is nothing but 25 divided by 128 L by H. That is the value of capital H. Is it correct? Yes or no? Yes or no?
Yes, sir. Correct.
H into Y. H value is 25 by 128 into L by H into Y is nothing but B. And this is your mx of beam, L minus x by L into x. So this is positive. This is negative because mx of b minus, okay, mx of b minus h into y. That is ILD of mx of beam minus ILD of h into y. Right? So this is the common portion. So this is considered as ILD for bending moment. सिंपल आहे. मोमेंट ॲट एनी सेक्शन घेतलात तर आर एमुळे एक मोमेंट येतं आणि एच मुळे एक मोमेंट येतं. आर एमुळे पॉझिटिव्ह आहे आणि एच मुळे निगेटिव्ह आहे. दोघांच्या व्हॅल्यू काढल्या आणि ILD ड्रॉ केली, झालं. दॅट इज ओके. ILD ऑफ फॉर बेंडिंग मोमेंट. इज इट ओके?
Yes, sir.
ओके, सिंपल आहे, जास्त काय अवघड नाही आहे. ओके, दॅट इज ILD फॉर बेंडिंग मोमेंट ॲट D. That is we are taken at point D. So shall I proceed? Shall I proceed?
Yes, sir.
Now, third, ILD for normal thrust. N. And radial shear, that is, it is opposite of the normal shear. Okay. Radial shear, it is opposite of the normal thrust. So whatever the diagram of the normal ILD of normal thrust, it is just like same, but it is the opposite sign convention. We have to check that, right? So now ILD for normal thrust. So for that, okay, suppose this is the your two hinge arch. So suppose I am taking any point, that is suppose at point G, right? Suppose I am taking any point, that is point G, right? So now this is your hinge, this is a A. I am taking any point that is G, right? I mean taking any point that is nothing but G, right? So with respect to that particular point G, so now I have to find out the value of normal thrust and the radial shear, right? So this is the value of H, that is H, horizontal thrust. This is at A. This is suppose point G. Where should I take? That is G, right? So the coordinates of the that point D, as you know, X and Y, okay, with respect to A. So we have to apply the unit load at a distance X from A, that is, and from that RA and RB is already it is known to you. Okay, so when the unit load is in between A and G, when the unit load is in between A and G, when the unit load is in between A and G, okay, so we have to consider the forces acting on the part AG of the arch. Okay, we have to consider the forces acting on the part AG of the arch. For equilibrium of this part, that is AG, for equilibrium of this part AG, we may realize that the part GB will exert the reaction on part GA at G. For the equilibrium of this part, we may realize that the part BG, that is B on this side, BG, okay, will exert the reaction on part GA at D. So there is a vertical reaction at D. लक्षात येतं काय म्हणतोय मी? इथं तुमचा एच आहे, इथं एक आहे वर्टिकल आर बी होतं, हा आर ए. तर मी काय सांगतोय, फॉर इक्विलिब्रियम ऑफ द पार्ट ए जी, ओके, we may realize that the part part BG will exert the reaction at G. Okay, at G. So we will consider the horizontal thrust HG now. I have to erase this. Okay, and for balancing, suppose this is your VG. R is upward, VG is downward. HA is towards right, HG towards left, right? HA towards right, HG towards left for equilibrium, as I told, for equilibrium, right? Now, if you have to draw the tangent, Understood? Yes or no? And perpendicular to this. Now, suppose this angle is theta, right? So vertical, with respect to vertical, this angle is also theta. So now, so normal thrust is acting in this direction, that is N, and perpendicular to this, that is a radial shear S. And this is your normal thrust. This is radial shear. Both are acting perpendicular to each other. Then we have to resolve this HG and VG along the normal thrust and along the radial shear. We have to resolve this. We have to resolve this HG and VG along the normal thrust and along the radial shear. So the component of the HG and VG, right? So component of VG in this direction is VG sine theta. Then component of HG is also in this direction, that is HG cos theta. Is it correct? Then component of VG, okay, along the radial shear, right? Along the radial shear, it is like this. VG cos theta, and component of HG along the radial shear, HG sin theta. Okay, is it okay? We have to take the reactions at B, that is exerts at G for equilibrium. So RA is upward, VG is downward, that is at point G, vertical reaction downward. HA is towards right, HG towards left for equilibrium. सरांचं लेक्चर किती वाजता असते? सरांचं लेक्चर किती वाजता असतं?
12:30, sir.
12:30 ना?
Yes.
हां ठीक आहे. Okay, so now next line. Next line add on. Okay, resolving the forces at G along the tangent. Okay, resolving the forces, write down. Resolving the forces. Resolving the forces. Resolving the forces. Resolving the forces. Write down. Resolving the forces at G along the tangent. And resolving the forces at G perpendicular to tangent. Resolving the forces at G perpendicular to tangent. Okay. I will give directly equation. Next line write down. Normal thrust n is equal to, remaining part we will discuss afterward, hg cos theta plus vg sin theta the next radius here S is equal to, remember this equation, hg sin theta minus vg cos theta. Right? So these are the two equations. Shall I proceed?
Yes, sir.
Now we have to consider first normal thrust, then the radial shear. So equation of N is known to you, hg cos theta plus vg sin theta. Now h value is already known to you, 25 by 128 L by H. So it is multiplied by only cos theta. That is the only change. This is the ILD of H. This is ILD of H. H value is already known to you. So multiply by only cos theta. That is ILD ordinate for this case is 25 by 128 L by H cos theta. Now only we have to find out value of Vg and then multiply by sin theta, right? For this, okay, if you have taken the point G, okay, so as usual, we have to insert the sliding device, okay, then the one is vertical upward or one is downward, second is upward, like this. So this diagram is known to you. 1 minute. So this shear force at any section is known to you, minus plus. So this is suppose x value, this is your L minus x. Suppose this I am taken as y2 and this is your y1. Is it okay? हे माहित आहे ना, लक्षात आहे ना? अच्छा diagram, shear
Yes, sir.
force at any section. Yes or no?
Yes, sir.
So now, what is the value of y1 plus y2 is equal to? Anyone, can anyone tell? In general, y1 plus y2 is equal to?
L minus X.
Not, no. आपण भरपूर न्यूमेरिकल सॉल्व्ह केले होते. इथं काहीतरी व्हॅल्यू होती, इथं परत काहीतरी व्हॅल्यू होती. ते सिम्प्लिफाय केले की आपल्याला एक व्हॅल्यू
So
भेटते.
one.
किती?
1, na, sir?
Right, correct, 1. So y1 plus y2 is equal to 1. This ordinate is 1 total, right? So by using similar triangle, y1 by x is equal to y2 divided by L minus x, right? After simplify, y1 is equal to x by L minus x into y2. So put the value of y1 in this equation. Put the value of y1 in this equation. So if you put x by L minus x, y2 plus y2 is equal to 1. Simplify, you get y2 is equal to L minus x by L. Please check. आपण शिअर फोर्स करताना सिम्पली सपोर्टेड बीमला हेच व्हॅल्यू येत होत्या, लक्षात असेल तर. येस ऑर नो? सिम्पली सपोर्टेड बीमला आपण ILD मध्ये शिअर फोर्स केला होता, तिथं y2 ची व्हॅल्यू हेच आहे. देअरफॉर पुट द व्हॅल्यू ऑफ y2, y1 इज इक्वल टू x/L. y1 is equal to x/L. Is it okay? Is it okay?
Yes, sir. Yes, yes, sir.
Okay. So further part we will discuss in next class. आता काही नाही, फक्त ILD ड्रॉ करायचे. तुम्हाला इक्वेशन माहित आहे, एन आणि एस VG ची व्हॅल्यू भेटली. VG ची व्हॅल्यू म्हणजे इथले तुम्हाला y1 आणि y2 चे ऑर्डिनेट भेटलेला आहे, त्याला मल्टिप्लाय बाय साइन किंवा कॉस लावायचं, आणि एच ची व्हॅल्यू आहे त्याला कॉस किंवा साइन लावायचं. एन आणि एस चं इक्वेशन रेफर करा, तिथं एच जी आणि VGच आहे, एकाला कॉस आहे, एकाला साइन आहे, एकाला साइन आहे, एकाला कॉस आहे. Okay, only we have to multiply by this y1 by cos theta or sin theta, or y2 multiply by sin theta or cos theta. Remaining diagram is as it is. HG diagram same aseल. We have to use the sign convention and then you have to draw the ILD. Okay, so only remaining part is ILD of the normal thrust and the radius shear. Is it okay? कोणाला काय अडचण आहे का याच्यामध्ये?